Okay, here are more examples. These examples I took straight from your book on page 361. And we're going to go over each and every one of them. Okay, we're going to do it the long way well, we're going to do it the short way first, and then we're going to do it the long way just to prove that the short way works. Okay, on our last video we learned that whenever we have a log with the same base as my argument, then this will equal that exponent that equals square root of 43, and you're done. That's what it is. Now let's prove it. If you don't know that rule, or if you are not able to remember it, then you can always go to your other resource, which is change your log expression into an exponential expression. So I'm going to rewrite this to do it the long way, okay? Log of 10 raised to the square root of 43. And that equals what? I don't know, so I write an x. And now I take my base, which is 10, that's not written, but I know is there, and I raise it to the x power. Remember, we take the base, raise it to the x, so this would be 10 to the x equals 10 to the square root of 43. And if you have equal bases, then your exponents must be equal, so x is equal to square root of 43. And you see how you got the same answer that I got without having to do any of these steps. Okay, let's do this one. We're going to use the same rule. Log base 10 of 10 raised to the x squared plus y squared power. Now, I know this is equal to the square root of x squared plus y squared because of that property we learned in our last video. Whenever we have a base equal to the argument, then this is going to be equal to the exponent. And in this case, the exponent is the square root of x squared plus y squared. This is the short way. The long way, I'm going to rewrite the log. I have log 10 raised to the square root of x squared plus y squared. Okay, and what does that equal to? I don't know. Now, we tend to use x as our unknown variable, but in this case, I'm not going to use x. Why not? Because x is being used by the exponent, and I don't want to say that this x that I'm going to get as a result is this same x value, okay? So since already I'm using x and y in my original expression, I'm going to say this is equal to z, and z is just another variable, okay? It's a value that doesn't have anything to do with this value, just to separate those two, okay? That's why I'm not using x. You can use any letter as long as you don't use x or y because it's being used here. So let's rewrite this as an exponential. I take my base, which is 10, I raise it to the z power, and that is going to equal 10 to the x squared plus y squared power. Now, if my bases are equal, then my exponents must be equal. So z is equal to the square root of x squared plus y squared. And that's what I had said originally. But this is the long way. Okay, let's do number 3. I'm going to rewrite this. The shortcut here, well, I know it's 1/5. Okay, because that's the exponent. If I rewrite this radical as an exponent, then this is what happens. Let me show you. I can have the natural log of e to the 1/5 power because I've rewritten the 5th root of e as e to the 1/5 power. And now the base here for the natural log is equal to the argument, so I know this is equal to 1/5. Okay, that's the shortcut from our previous video, but let's do it the long way. The long way would be the natural log of the 5th root of e equals what? I don't know, x. I can use x here because there's no other x in the original expression. Now I take my e, that's the base of this natural log, and I raise it to this exponent, so I have e to the x is equal to the 5th root of e. E to the x is equal to e to the 1/5 power. X is equal to 1/5. Okay? And you got what we said in the beginning. Now for this one, we also saw this in the last video. Whenever I have a base equal to the base of this log, this is going to equal the argument. We saw this in our last video, but if you don't remember this, always go back to basics, which is, well, if this is written in exponential form, let's write it in a logarithmic form. So let's write e natural log of 34.17 is equal to what? I don't know, x. Okay, and now let's rewrite it as a log. So if this is the base, that means I have a natural log, and this is my exponent, so this is what goes to the other side of the equal sign. And this is my argument, which is what goes here. So here's my log expression. I have the natural log of something equal to the natural log of 34.17. So that something must be 34.17, which was the original number we said if we use the shortcut. And we have our last problem here from your book. Again, I know this is equal to x squared plus 2y. Okay, that's a shortcut. Whenever I have the base equal to this base, then this will equal the exponent. But let's do it the long way. I have the natural log of e raised to the x squared plus 2y power equals what? I don't know, but I'm not going to use x, I'm not going to use y, I'm going to use w this time, okay? So there's no conflict with this value and this value. So now I rewrite this as an exponential. Remember, my base here for natural log is e, so I'm raising e to the w power is equal to e x squared plus 2y, okay, to the argument. Now if I have the same base, then the exponents must be the same. So w is equal to x squared plus 2y, which is what we said it was going to be equal to. And there you have it. These examples, again, straight from your book. I think they were part of your homework. Some of you had said that you didn't understand how to do these when you turned in your homework. So there you have the answers. Go back, try them on your own. And if you need to pause or hit rewind, go ahead. I'll see you in the next video.